It is a delight to give a brief overview of the Materials World Module program. Materials technology has sustained human civilization of over thousands of years. Today, advanced materials is the backbone of all industries. Thus, MWM is designed to connect core science and math concepts to the world of applications. MWM integrates the many disciplines of science, such as physics, chemistry, biology, and engineering and math. It was developed by teams of teachers, research professors, and professional publishers. Our goal is to improve science and technology literacy for all citizens and thus improve their quality of life along with the economy of the country. Today we have 60 modules with booklets, material kits, online animations, simulations, and games. MWM components consist of a hook or an attention grabber, a series of activities resulting with a design project. Students find discovery starts with inquiry, and design projects validates their full understanding of the basic concepts. Nearly all students are thrilled with their designs. Student assessments show MWM learning outcomes have a 2.5 sigma or standard deviation gain that is independent of gender, ethnicity, rich or poor schools. Over the decades, NSF has funded $20 million in development costs, and we have seen worldwide impacts on students.
They're giving us the materials, they're telling us this is what you have to make, use anything you want, go ahead. So they're letting us use our creativity and our minds and everything.
Each module has been field tested in science courses nationwide, including chemistry, physics, biology, earth science, physical science, technology, and engineering. Evaluation currently underway points to significant gains in knowledge by students from diverse backgrounds. Materials World modules give students real-world experiences with cutting-edge science, link scientific inquiry with technological design, build social skills through group work, aligns with science content standards and surpasses process standards, enriches teaching.
If you want to continue the pattern of curiosity, all right, to me that's very important. Invention coming from curiosity. And so we want to have a module that is curiosity driven, so we need to make sure that the students ask questions. We ensure kids have hands-on activities, and we also give them opportunity to design and make something. And so those basic principles, when you put together, it's very rich.
MWM has a philosophy that the student is at the center of the learning experience, and the teacher's job is to facilitate the learning and to guide a student along by using key concepts within a scientific framework. Students learn to apply scientific and mathematical knowledge. MWM also improves both laboratory and communication skills.
The student is making their own hypothesis, their own procedure, collecting their data the way they see it, making their own data tables, generating their own conclusions, and presenting all this information to other students who've just done the same thing, but probably a little bit different way. And then you get the student-student interaction where they're questioning each other's experiments. Instead of just sitting back and going, I wonder what grade I'm going to get on this, I hope I got the right answer, they see there's more than one possible answer, which is much more real world.
They immediately expect to be putting their hands on things, to be asking questions, to be standing up and talking to their partners or saying, let's try this, and talking to the teacher as if they're a peer or a colleague, and maybe asking for advice and instruction, but really saying, we would like to try this, and this is how we're going to do it, and rather than asking, what should I do next, what should I do next? Because the idea is that they're empowered to think on their own as individual learners, and that's what inquiry is really all about.
For me, the biggest strength of it is it really demonstrates to kids what science is really all about. And it's more than just a bunch of facts that you memorize for a test, that there's applications of these things that seem very esoteric when you learn them in class to the real world and things that they experience every day.
I'm doing hands-on stuff. Hands-on stuff, I think it gets to your brain better than listening and taking notes and stuff. Well, we take notes and listen and stuff, but doing hands-on makes it stick in my brain better. When you make a mistake, it's not wrong. So
And you can learn from the mistakes
yeah.
and improve on your creations.
I think I'll always remember this stuff because I actually experienced it instead of reading about it and then trying to understand it but not really understanding it. Here we read about it and talked about it and then learned it by doing it, so it's definitely in there now.
It's like I'm living science, not reading about science that has been done by someone else. I'm learning it for myself and I'm making my own discoveries.
It gives them a clearer picture of the creativity that can be involved in science, because that's really what we need. We need a new generation that's full of the content of science, but have seen it applied and are ready to take their creative minds and just go after a problem.